Some substances conduct electricity in both solid and molten states. Others conduct electricity only in molten state. The setup below can be used to test for substances which conduct electricity in molten state. A rod of a metal or non-metal is used to conduct electricity through a molten or aqueous state. The negative electrode is called a cathode, and a positive electrode is called the anode. The setup below can be used to test for substances which conduct electricity in molten state. The electrodes are dipped into different substances. Observe if the bulb lights or not. Lead-2 iodide and lead-2 bromide do not conduct an electric current in solid state because their ions are held firmly by strong electrostatic forces and these cannot move. However, they conduct in molten state because melting weakens the electrostatic forces, thus enabling the ions to move and thus conduct the electric current. Sugar and sulfur do not conduct electricity both in molten and solid state because they have molecular structures and lack charged particles to conduct the electric current. The setup below can be used to test for substances that conduct electricity in aqueous state. Some substances conduct electricity in both molten and aqueous state. Others do not. The setup below can be used to test for substances that conduct electricity in aqueous state. Aqueous solutions of salts, bases, and dilute acids conduct electricity. Sodium chloride, copper-2 chloride, and dilute hydrochloric acid conduct electricity. Sugar and urea do not conduct electricity. Aqueous solutions or melts, which conduct electric current and are decomposed by it, are called electrolytes. Aqueous or molten solutions that do not conduct an electric current are called non-electrolytes. In this lesson, we shall discuss the effect of electric current on lead-2 bromide. The setup below can be used to show the effect of an electric current on solid and molten lead-2 bromide. When an electric current is passed through lead-2 bromide, it is decomposed into lead metal and bromine fumes. This process of decomposing an electrolyte by passing an electric current through it is called electrolysis. Molten lead-2 bromide is an example of binary electrolyte. This is because its melt contains lead-2 ions and bromide ions only. Note that the experiment must be carried out in a fume chamber. This is because bromine fumes produced are very poisonous. Electrolysis is applied in such processes such as extraction of metals such as sodium, magnesium, and aluminium by electrolysis of their molten compounds. Purification of metals such as copper. Electroplating of metals such as iron to improve their appearance and prevent corrosion.